So in the previous session, we have seen that so we had two limitations from there. Like there, one was like the data and the, like address and data. What we were trying to send out was a fixed. Like we are always writing a fixed data at the fixed address. And then one more thing, what the problem was there was like we always used to write to an address and then do a read. It was not necessary to be done in that way, correct? So because we were doing in that order, there were some simplifications what we had. So the other issue what we had from the previous session was the logging, correct? We discussed that the logging messages can be very difficult, and we want to only flag or have some kind of control in which we can flag or add and delete messages as necessary, correct? So in this session we are going to take on like how do we randomize the address data and then various considerations with respect to that. In the next session we'll take on logging. So in randomization, what we are trying to do. So in the previous video, you might have seen that we were based on this plus arg num read write, we were looping through that, and then based on num read write, what we were doing, like we were only writing that address, like the address was I and data was also the I variable, correct? So it was always the fixed one. Now what we are doing for each iteration now, we are trying to randomize the operation. So if my number of read write is like 1000, for each of those 1000 runs, I will randomize this read write operation, the address and data, and then I'll perform this appropriately, correct? If the randomized read write is 1, then I'll perform a write. If my randomized read write value is 0, then I'll perform a memory read. And again, like when the randomized, like when this particular bit is set, what address I use, again I use the random address and random data. So these are like the enhancement to this the test bench what we have done. And then similarly we have like appropriate like additional variables in our like design. Now this has a problem, correct? Earlier we used to always read to a location where we were actually writing it, so we know what data we had, correct? Now in our case, like it can so happen that the first random read write is a read, correct, to a location which we have not written. So how do we check, correct? Like because our scoreboard or the monitor would not have created expectation for that location where the write was never done, correct? So when we read to that location, we are going to see a failure there, correct? So how do we tackle that? So on the right hand side, if you see, we discussed that mem scoreboard was our memory which we were using to keep our expected data. And then whenever there was a write, we used to write that location with the expected data. And whenever there was a read, we used to extract the like from that mem scoreboard variable, like from the memory, the value stored at this location, and then we used to perform a check. But in this case, our read can happen even before the write, and since we are using associative array, that particular location would not exist, correct? So this is the check what we are trying to do here. Like we are first checking if an entry exists in the scoreboard, this means that there was a write previously to this location, and then we can check the expected data whatever, like, and it has to match. So when this mem scoreboard dot exist is a function which is allowed for any associative array, and then we have to provide an index. The index in our case is an address. So what we are doing, we are checking whether this address exists for this mem scoreboard. If it exists, this is the same part of code what we had, correct? But if it doesn't exist, correct, there can be two things. Like if it doesn't exist, then we are performing a read, and since we are performing a read, our memory model is using a 4-state data type, so it will return the default value of the data type, which is X, correct? So in that case, what we are saying that if the entry doesn't exist in our scoreboard, the data what comes back, we have to check against X, because we know that this is the default data type value. And again, like if it is X, we say it's passed, but if it is any other value than X, means there is some issue there as well, correct? So that is present. Now again, this default value of X is not like scalable. We have to we'll see subsequently how to control this, But for now we know that our memory model is using 4-state data type, and then this part of code tackles that. Now let's go to the code. So in this case again, we have discussed these changes. So these are the changes what we have done. So here we are not passing num read write. Let's pass num read write equal to 1, and then just try to give it a run. Now if you see, like in the earlier case, for each loop variable we used to do a set of read and write. In this case, num read write actually represents one transaction, be it a read or a write, correct? So in our case, if you see, this has performed a read, which means that when we randomize this, when the loop entered, and then the first time when this variable was randomized, this value was 0, so it performed a read to a random address. The random address was 1, which it has received from this, and then when it tried to perform a read to that value, correct, because this write never occurred to that address. In that case, we were expecting expected data of like the reset the reset value for that like logic variable, correct? So in this case, the memory is defined with a 4-state variable type, so it will return the default value of that variable, so which is x. So again, because we had the other branch in our we had this part of check which was checking. So in this case, the memory scoreboard exists check will fail, so it will not enter this, and it will check enter this part of the logic, and then if the expected data is x, then it would flag a pass. So you would see this pass message is from this, because the expected data and actual data, you can see it as both x, correct? So this is one thing. Now you could do like increase this to 100 and then check whether like this actually works. So you can see some random location, some random data, and then there is no order, like fixed order. The number of writes can be more, the number of reads can be more, and then it can be iterating or something like that, correct? And we see a number of pass messages here, correct? So this is the way we control the randomization of data. This is again like simple random. There are like much more complex and much more detailed feature of random, like how the randomization can be done, but this is just to get you started on this. Now having discussed this, let's revisit the logging in the next video.